What if the very codes protecting our digital lives could be unraveled in mere seconds? And what if, in the same breath, new codes far beyond the reach of any hacker emerged? Welcome to the dual-edged world of quantum computing and cryptography. For decades, cryptography has been the cornerstone of digital security. From online banking and encrypted messaging to national defense systems, classical encryption methods like RSA and ECC have safeguarded our secrets by relying on the immense difficulty of factoring large numbers or solving complex mathematical problems, challenges that stump even the fastest supercomputers. But quantum computers don't play by classical rules. With the emergence of quantum algorithms, particularly Shor's algorithm, the landscape has shifted dramatically. A sufficiently powerful quantum computer could factor massive integers exponentially faster than a classical one, rendering today's encryption methods vulnerable. It's no longer a theoretical threat, it's a ticking clock. Once quantum systems reach a certain threshold of stability and scale, much of our current cryptographic infrastructure could be rendered obsolete overnight. But here's the twist. Quantum computing doesn't just threaten encryption. It also offers the tools to reinvent it. Enter quantum cryptography, a groundbreaking field that uses the very principles of quantum mechanics to secure data. Techniques like quantum key distribution, QKD, don't rely on hard mathematical problems, but rather on the fundamental laws of physics. Any attempt to intercept a quantum key changes its state, immediately alerting the sender and receiver to a potential breach. In essence, QKD makes eavesdropping not just difficult, but impossible. While quantum computing may be the end of one era of cryptography, it's also the dawn of another. Researchers worldwide are racing to develop post-quantum algorithms, encryption methods resistant to both classical and quantum attacks. Institutions like NIST are already working to standardize these next-generation solutions, ensuring we're prepared for a quantum-enabled future. In the years to come, quantum literacy will become essential, not just for cryptographers and engineers, but for anyone invested in the future of cybersecurity. Understanding how quantum computing both breaks and builds digital defenses is no longer optional. It's critical. Do you think we'll achieve quantum-safe encryption before quantum hackers become a reality?